This question here is a question from liquid expansivity, okay? Expansion in a liquid. The previous question I have been treated is all about expansion in a solid, but this question now is about expansion in a liquid. Expansion in a liquid, two things are involved. The liquid will also be expanding while the container holding the liquid is also expanding. So before we now get the real expansion, we must combine both the expansion in the container holding the liquid and the expansion of the liquid itself. And in expansion in a liquid, we talk of volume, okay? So we talk of volume because you cannot measure the length of a liquid, but you can only measure the volume, right? So now we're speaking of the volume or the mass of the liquid, okay? So now let's calculate it. Now the thing says that gamma is equals to gamma R is equals to gamma A plus gamma C. So this one is the real cubic expansivity of this liquid in a container, okay? The real cubic expansivity. Why this one is the apparent cubic expansivity. The apparent cubic expansivity of the liquid, okay? Why this one is the cubic expansivity of the container holding the liquid. Cubic expansivity of the container holding the liquid, okay? So now it will now be the whole thing, the real cubic expansivity of the whole system will now be equals to the apparent cubic expansivity of the liquid plus the cubic expansivity of the container holding the liquid, okay? Now, yes, it is this one they say we should calculate. The question say a density bottle contains 44.25 grams of a liquid of 0 degrees Celsius and 42.02 grams at 50 degrees Celsius. Now calculate the real cubic expansivity of the liquid. They say we should calculate this thing. And the linear expansivity of the glass because it's a density bottle. Okay, so the linear expansivity of this glass, the density bottle glass is a glass. The density bottle is made up of glass. So the linear expansivity of the density bottle is 0.0001 per Kelvin. Okay, now in order to calculate this real cubic expansivity, which is this one, we will now going to get the apparent cubic expansivity of the liquid plus cubic expansivity of the density bottle holding the liquid, okay? From the question here, this one can be gotten easily, okay? The cubic expansivity of the glass is the same thing by saying 3 times alpha, remember, which is 3 times 0.00001, okay? We now have 0.0003 per Kelvin. So we have gotten this one, okay? Now, but is remaining this one. This one has formula that we use to get apparent cubic expansivity. Apparent cubic expansivity has formula. Apparent cubic expansivity is equals to mass of the liquid expelled all over mass of the liquid remaining times change in temperature. They gave us the question in mass, but at times they will give you the question in volume. So if the question is given in volume, it will now be volume of the liquid expelled all over the remaining volume of the liquid times change in temperature. So you remove mass and put volume, okay? So nothing still change. You work in volume or mass, it depends. I still remind you that this formula is what we use to find apparent cubic expansivity, okay? Apparent cubic expansivity now becomes when the liquid initially is 44.25 at 0 degrees Celsius, and when we heat it to 50, some liquid just expelled from container because the volume has increased because of increase in temperature, right? Now it will now be the mass of the water expelled will now be 44.25 minus 40.02, okay, all over the remaining liquid. The remaining one is 42.02 times change in temperature, which is 50 minus 0 is still 50. Now when we subtract, we now have 2.23 all over, then we multiply this with our calculator to now be 2101, and when we divide, what do we have? 0.00106, right, per Kelvin. Now calculating for the real cubic expansivity now, which is this formula. Our real cubic expansivity will now become apparent, which is this one, 0.0106 plus cubic expansivity of the container, which is 0.00003. So when we add it, and give us 0.00107 per Kelvin. So that is the real cubic expansivity they are asking us, okay? So that's how to solve expansion in a liquid, okay? So the solving is different from expansion in a solid. Please share the video, follow me on Facebook. Remember to click the follow button and subscribe to my YouTube channel. Thank you so much.